All right. So
let's go.
All right. Awesome. So the idea here is to insinuate kind of you guys to the subject at hand and hopefully have a jolly good time after the actual part of presenting things. This is pretty much kind of like a bit more shorter version from the excellent set of slides the author of this Python library has written. I'll mention it in the end, like you can easily, well, of course, Google it already, but I'll make a special note about it in the end. And also, while the examples themselves are written in Python, the concept that is kind of the main thing here is totally programming language agnostic or much more generic. It doesn't apply to Python only, but it's more general idea. So, and I already like apologize for a really contrived set of examples. But yeah, you'll see. So design by contract, that's the main idea. This is something that is built in some languages. For example, AFL have this so that you can create these formal contracts that specify how your functions must work. Not just should, but they really must work. And by this, I mean that they have these pre and post conditions that you need to ensure in your implementation that it really works that way. So the idea is kind of like mathematical in a sense that you want to ensure that your program is valid and it is sound. And kind of like same question that people have about using assertions versus using assertions versus checking exceptions. You shouldn't use design by contract to try to understand that, to detect invalid input. For example, take a simple example of a web application that has some sort of input form for user data. You shouldn't use design by contract to ensure that that form has valid data. That is something you do as early as possible in the form input handler. Of course, you can have any garbage there. And afterwards, you know when you have processed that data, that what is the valid set of total inputs that can be there. And that is where kind of design by contract kicks in. And you'll soon see examples how to actually use it. Another kind of important thing maybe to notice immediately is that one could also ask that how do these relate to testing if you want to improve software quality and you already have like really good test coverage in your code. Well, it's a good thing. Test coverage and good tests help new developers to get familiar with the code and so on. And you can also ensure that same things don't fail more than once when you have implemented fix. You implement test that can, well, first you actually hopefully implement the test, then you make the fix, and then you have that same test there forever, ensuring that it won't happen again. Kind of very important thing to have, but these pre and post conditions, they are always running. So many people who believe in this kind of programming paradigm or design paradigm have these conditions also in production all the time. This Python thing is a kind of exception because this is a library. You can also turn this off. But for example, if you would use language like AFL or something similar where you have those built into the syntax of language, then you probably wouldn't turn those off. But I guess we soon need to get into the meat of the matter. And one more view how to kind of think of this is that I guess this would be maybe even the first thing, like what is the idea in design by contract? Well, you have types, especially in statically typed languages. Types are very important because compiler is able to infer what kind of functions make sense, what kind of function calls especially make sense. And this is sort of formal extension over naive type systems that is achieved through pre and post conditions and invariants. before we go to the first example of preconditions, very short invariant recap. So invariants are things in code that you know that need to be always true, no matter what. Even if you have a invariant that applies to lists. Lists are common examples. Those invariants should hold also true for empty lists, which is usually very easy thing to do, because when you loop over an empty list, you just don't loop over anything. And here's a kind of like concocted example. I want you guys that if you have this kind of data structure that is silver gray tree, and there is this rule that any node on the left side of any arbitrary node in that tree is always balanced in a way that it is less than the node on the right, then you would write this invariant, this assertion in the middle, even though it's it's just a plain assert, nothing new here. But you should think that as an invariant that holds always true no matter what. This might seem at this point kind of artificial, or kind of like some delusion of grandeur thing, that why to call simple assets? I've been using assert 20 years or so. Who is this guy talking about invariants? Like, they are the same thing, but the idea is to get this idea of that what an invariant means from the perspective of contracts. And the same follows this if node silvery. Let's agree that in this imaginary silver gray tree, we have this rule that if a node is colored silver, then all the nodes that are children must be gray. To be honest, this is not actually a totally contrived example. There is a data structure that has very similar invariants that should hold always true. So that's about invariants. These are things that at least I think most of you hopefully have been already using a lot in your daily programming tasks. So now the first example on contracts, both for pre and post conditions. I wonder actually, do you see my mouse cursor? Anyone? No. Okay. So I'll just talk then. So the non-empty prices. Note that this is a decorator. What is really nice in this library that when you import this single function called contract, or this one decorator from the library, that's everything you need to do to get started with Pi contracts. So the name must match. In the decorator, the first parameter, non-empty prices, gives the contract in string form. You can also give these as type hints. Python 3 point something introduced type hints, and Python 3 point something, I don't remember what has those built-in innocence that you don't even say from typing import. But in any case, you could use those, but then the problem is that because these are much more powerful, there is much more expressive power in PyContran types. They are not obviously compatible with any type checking tool that you would use. So that's why I use these decorators. This is also the way the author recommends these to be used, because they are so concise and clear. And kind of the nice thing is that you don't have to touch the actual function at all. So this very short contract gives actually two nice conditions, because first in the brackets we see there is this short snippet that says that it must be greater or equal to 1. So the first part is the list contract, and it basically says that you have to have list that has more than one item. It could be, I guess, if not arbitrary arithmetic expression, it could be kind of like, there are many options you could put there, but this is one of the most common. This way you could say that this list cannot be empty. And the other constraint or contract, like the author wants to talk of this, is that all the items in that list must be positive. 0 is not included. And then there's another much more simple final condition or contract on return value, which is that always this function needs to return something that is greater than 0.75. This is, again, really simple concrete example, but from the implementation, you see that it actually should hold, because we have this base price that is always added to something. And because the list only contains positive values, you should be guaranteed that, unless this has bugs, I'm not guaranteeing it has bugs. But if it has bugs that breach this contract, you get contract violation exception. So you don't need to kind of worry yourself that, does this really hold always true? Otherwise, I would, in this case, write an assert statement here that expresses that return value, but using contracts I don't need. Let's go forward. A bit more details on contracts, how to deconstruct those expressions. There are three simple expressions. The first decorator expression is kind of very similar to the one we saw. First, there is this list contract that is exactly the same that I used. List must be non-empty, and all the values inside need to be more than 0. I could also add constraints on types, like all those values must be float values, or those values must be integers, or even complex numbers, but this is just a simple example. Pay attention to dictionary contract. It's very similar, and if you use types in what was the term? Type hints in Python. They are very similar. Basically, you just kind of lowercase, and then there is this additional power of expression that you have through these arithmetic expressions. So if you compare this dict contract and list contract, they are very similar. Instead of length, I mean actually, you have the very same length contract in dictionary, but instead of type contract in the end, because dictionary contains both the key and value, you use dictionary syntax, in this case, to present that keys are strings, values are tuples that contain in turn strings and floats. And then the last one is very simple one. One could ask that, how do I specify that I don't care about values of the dictionary, I only care about keys? Then you could say this string star to the dict parameter, to dict as parameters in the, there is actually missing parentheses, but just notice that. But you get the idea. Star is just like any type. And then more of the basics. In the bottom part, you see that, okay, I can use Boolean expressions. I can use pipe to basically say that it is a value union type, or tagged sum might be familiar to you. Basically, you say just that type can be any of these values separated by pipes. It's basically an OR expression. And well, and is just a comma, which is something you do often. So there are these very short syntactic shortcuts for specifying additional allowed constraints. And it even supports NumPy, which is a really good news for those who do data analytics or science or something similar. You can give this kind of simple expression that, hey, I have this in array, it needs to be always 3 rows and some arbitrary number of columns. Uppercase single letters in Py contract, DSL if you like, they mean integers, and Py contract automatically without this C must be at least 2. Py contract would know that this C refers to an integer value. It could be any integer, but there is this additional constraint after comma that it also needs to be at least 2. Then the a bit more complex example. Could it use custom type definitions? Sure, you can have custom classes. So without need to kind of dive deeper into these very simple concrete examples, there's the base class that is this verbal. You can instantiate it with name. There's this greet method, and then you have 2 derived classes that inherit from this verbal class for cat and dog, because of course that's the obvious example you want to use. And Now I specify a function that has as a contract precondition that the first parameter must be of the type verbal. And the next contract is a bit different. For one thing, note that when I add additional constraints, I could just put cat there exactly like I put verbal above if it was only constrained on the type. But because I want to introduce additional constraints, I need to put it as a string, which means that for some reason, probably to help the parser, I need to prefix class name with $. This is kind of one somewhat awkward thing, but mentioned clearly in the documentation. And know that I can actually make contracts based on attributes. So this very simple precondition here requires that this first argument not only needs to be a cat, it needs to have an attribute called name that must be a string. And also this function takes another optional parameter, and the way to make it optional in PyContracts is to use union type, which we covered already, that you just separate by pipes. So this takes either an integer or it could be none. Then there's a test code, very short one. I wanted to kind of like fit everything into this one slide. Sorry for that, this is kind of like convoluted. But this test method is something I could immediately run with PyTest. So the first one, this say hi, fulfills the contract because a dog is instance of verbal. So this behaves exactly as you would expect. If you say in a contract that it needs to be of this type and you pass it a subtype or inherited class instance, it is kind of, I guess, intuitive or should be intuitive that subtypes should be okay. Same thing on the next one, this pet fluffy foof was contracted in a manner that it needs to be a cat that is passed to it. So this passes as well. But then sometimes when I just brush accidentally mouse it switches to the next slide. So this first assertion that asserts that this contract not respected exception is raised. This is because this pet fluffy fluff requires argument to be instance of cat, but dog is not an instance of cat, it's a dog. So this fails the contract. And the next one satisfies the contract for otherwise it's of the correct type, but you need to give name attribute that is a string, but this cat is given an integer. So it fails because cat constructor is given an integer argument. So basically, if you lost on the details, worry not. The base idea is that you can create totally custom classes in PyContracts and use those as types in your pre and post conditions. And it has even more awesome stuff. If any of you have read about, what was the term? This is a thing in Haskell newsgroups. It's not derivative types, it's something a bit different. But I mean, what is awesome here, if you check at the function signature, I don't, dependent types, yeah, that's the formal word for the thing I was looking for. Because here you have this expression that this takes an accumulator as the first argument that has n values. And in returns, you can say that whatever I return, the list needs to have +1, more than one value than what was there originally. If you would need to create a function that uses some recursive helper function, this is really nice helper tool, because often in recursive functions, when you're kind of, you want to approach base case, otherwise your recursive code would never finish. And this base case is either that you have your list is as long as some target value or it is empty. So maybe even a better example would be that returns list n-1, meaning that when the list size is 0, often it means that your recursion has finished because accumulator is empty, or the other way around. But this is really nice tool if you do, well, functional programming, for example, in Python. Custom contracts. Again, I need to apologize to you people. This is, I guess, the last example here. So this shows you the true power of Py contracts, because if there is no built-in feature and you can create new contracts by just using this new contract decorator, you can have arbitrary type contracts. There is no limit to what that contract can do. So you can do anything as a contract that you can code. And if this is not a mind-blowing thing, what's wrong with you? This is best thing since sliced bread. So I wanted to create this, sorry again, concocted example that I don't know Polish language at all, but I created this hyper smart machine learning algorithm. Here you can see this def Polish that is able to infer whether the string passed to the function is actual Polish language or not. How it does it, it takes the number of vowels and constants, and if the ratio of constants to vowels is greater than math.py, then it's obviously Polish. So, sorry, if you go to the next part, there is this politely ask function definition. Now I give two constraints. This precondition says, first of all, that it needs to be a string. By the way, actually, I should have added there also that it needs to be non-empty string. This is kind of bad in that sense, but totally something you could express as a condition. And in addition to being string, it needs to be Polish. And then if you check the test, there are 3 words which it passes to function, and all these 3 words pass a contract because the Polish function definition holds true for all those inputs. But because it doesn't hold true for the last one, because there are, 3 vowels and 3 consonants. So definitely that word, I don't even try to pronounce that. Sorry, I couldn't do that. What's the word actually? The last one? Jake, anyone? Can you say what was it?
Which word?
The last one.
Ołówek?
Yeah.
We don't know. We don't speak Polish either.
Ołówek. I can tell you, it's ołówek.
Ołówek.
Yes.
I shouldn't even try. Sorry. What was that again? What does it mean?
It's the pen, or not the pen, the crayon.
Right. Like pencil. Or pen. Yeah. Okay. Yeah. So that really sounds to me like a non-Polish thing, because you have way too many vowels there to be Polish. So can't be. I guess that's about examples. So one other question you might have: does this coexist with type hints? But I think I'll go over this because we already kind of discussed this. You can do that. You can use these contracts as type hints, or you can use these in parallel with type hints by having both the decorator there and have type hints as you normally do type hints. But the nasty thing there is that there would be lots of duplication. So how to solve this problem? I don't know. I haven't used this in production yet. I'm definitely going to use. But I guess one kind of, if you're interested in trying this out, is that especially if you already have code that has type hints, would be to kind of elevate those, because you can express anything with Py contracts that you can express with type hints, but it's much more powerful. So you could kind of augment your type thing to higher level and go with Pi contracts and profit. Yeah, so especially if you're in critical domain, as both me and Jake are, at least, it's something that I would kind of really like to see us using more, but of course we need to get some more experience with this. One other very quick thing, one could ask that, okay, what about performance? Definitely there is performance impact when you have this turned on, because if you have very complex type definitions, then definitely it'll take some time, because these are called for every single invocation of your function. If your function that has a contract is called in a tight loop hundreds of millions times a day, you probably want to make that contract either very simple, or maybe you even turn that off in production. So this is a really nice thing. You can have as complex, as hard, as strict types as you ever wish. Like, you can basically make your Python program Haskell if you like, or Idris, and turn that off in production because you want to poor Python kind of be able to actually get the result in some sensible time. So there are two ways. You either call the method to turn them off, or you set this environment variable. Some stuff I wish I would have, but I don't have in Pi contracts. Well, no algebraic data types, and most of all, no recursive definitions or contracts, because, for example, I would always like to express in a strict manner that this is a JSON dictionary, and JSON dictionaries can't contain anything. They need to have strings as keys. But values are a problem, because the JSON value can be either a scalar or JSON dictionary that contains JSON values. So it's a recursive type definition, and the DSL isn't sort of capable of expressing that. But it's actually not that big of a problem, because you have these new contract custom types that you can declare. So nothing is preventing you from creating recursive, even co-recursive, if you want to go crazy, type definitions using Pi contracts. And this is really a great thing. This is like, not all the languages are even capable of expressing such type constraints. And also callables, they are missing. You can't, like in typehints, actually I kind of lied. I said that you can express anything you can hear. Well, you can't express callables in Pi contracts unless you use the custom type definition. Yeah, so that's about it. Definitely, if I could add all pick your interest, I recommend you to check out this first link. That is the original set of slides written by the author, and it's not long. It covers it really well. And other one is kind of totally unrelated, but not completely, in a sense that we talk of invariants, things that.
Wait, Ed, someone muted you by accident, I guess. Can someone unmute?
Totally understandable. I unmuted myself. I would have done that long ago if I were you. So yeah. But yeah, this Pi hypothesis is the way to, instead of making simple test cases, assert that 1 equals 1 and stuff like that. You express tests through invariants that are very closely tied to the idea behind design by contract. So it's a kind of similar thing. And finally, obligatory cat picture and a good quote by Andrea Sensi, the author of this tool. So yeah, if it's not powerful enough, well, you might want to consider Haskell. So,
and with advertisement for a completely different language, we thank you, Ed, for giving us amazing talk.
That muting was totally on time.
It was a sign. Anyway, yeah, probably you can hear the virtual clapping that's now your way. Thank you very much. We absolutely appreciate it. We have one question. Maybe we have two. I will give a theoretical one. Would you like to see Pi contracts being included directly in default Python vanilla in future, or rather not?
Yeah, really good one. I kind of, if I try to put, well, I was about to say Guido van Rossum's hat in my head, but that hat is way too large for me, and also Rossum is not officially leading Python anymore, but I would avoid complicating language unnecessarily. This is already doing such a fine job that, to be honest, I was thinking that I don't see any benefit it would give. It might be even the other way, like in some languages, they have chosen the other opposite compared to Python. I think that this is one thing in Rust, that they made this decisive choice to not include all the batteries in the standard library, because they understood that they will be always out of date. There will be always much more better solutions in the common third-party library. So I guess the same thing could go here. I wish that the author would continue this already awesome project. He hasn't abandoned it, but it's kind of like low volume. There are not much changes. Hopefully my kind of dream would become true if I could contribute that repository. Definitely I'm intending to, by some means. At least I'm thinking of already creating this custom contract for JSON dictionaries, because that seems to be a thing I do in many Python software projects. But here, maybe I guess it would be good in a sense, because of course that would be much more common that people would use this if this was built in the language. But I don't see that as a big minus if it's just a library.
Good, thank you. Now we have a double question. One part you already answered, but the first one is, does it run in CPython, and how does it affect performance? So I guess the performance part we went through, but can you run it on CPython?
Yeah. It's a good question, like both parts. Definitely, it precisely runs. Sorry, actually, CPython, like you mean the standard vanilla Python. I'm kind of ashamed to ask this, but I kind of unsure always. Like people refer to CPython as the not PyPy or anything more kind of standard Python, right?
Stepan, can you clarify, or we go with the standard?
Yes, it's a standard Python interpreter.
Exactly. Yeah, that was my guess. So whatever you pull with Homebrew or PyEnv, which is the thing I always use because I need to work with multiple Pythons, it works with that. And overhead is really small. It's 0 if you turn that contracts off with the decorator I showed at one point. If you do that before you have loaded your contracts, there is literally 0 overhead, and very small overhead if you do that later, which actually gets to one important point. You can, if you want to, you have this super critical code that maybe deals with financing or something like that. You could turn off your contracts because you don't want the system to crash in some, very rare, weird anomaly, but you want to have this really core function that does all the awesome, like millisecond trading, millions of transactions per second or something. You want to have those there. You can do it with pre-contracts. I can't hear you. Somebody muted check. You self-muted.
Yeah, I just muted myself. I would like to blame someone, but I always blame myself. Anyway, Holin asked, can you express the recursive type JSON check in a custom contract?
Yes, and that's the first thing I'll at least try to do, and I'll confess my shame to Jake if I can't do it later on. So yeah. I see no reason why you shouldn't be able, because you can have custom contracts that are arbitrary, as long as you can code it in Python.
Awesome, perfect, thank you. Does anyone have any other question about PyContracts? Please shout. Well, okie dokie. So what we can do now is, well, first of all, some information additional to the original one. If you still have any lightning talk, you have a few minutes to send us the topic and you have the floor. Otherwise, don't forget that this is mainly plan B for our usual Pyvo. We have it usually in Artbar, but currently because of the situation, we can't do that. So hopefully once we are back on track, we will be able to meet in person. But if this proves to be worthy, we will continue with having half live and also partially virtual meetings in parallel. Great.
Let me just stop the recording here, right?